Hey Twitter, it's Ghosting Danny. If you guys have been following along NAVSA's, the North American Victorian Studies Association's Twitter page, you might have seen a cipher that Lorenzo posted for us to try and solve. I'm happy to say that I solved it pretty quickly, and so did Pax Victoriana and Lindsay E.R. O'Neill. And so I thought I'd just give a very, very quick primer lesson as to how I did it, just to show my work and make sure that you guys, just into for funsies, I guess. So if you haven't done it, if you want to try it, this is going to definitely spoil it. So just keep that in mind. If you want to stop watching, now's the time. The first thing you have to do is sort of write out what your code is. Um, Remembering that a code is really just a way of hiding information. So in theory, whoever you're trying to communicate with knows the secret of decoding it so that your enemies don't find out what it is you're trying to say, but whoever it is that you're talking to definitely knows. Um, Based on what we know already, so it's coming from the North American Victorian Studies Association, so it's probably going to be something Victorian. It's going to be, I'm looking at this and I'm seeing spaces, so I presume that these are word functions, like these units are words, rather than something more complicated. So with that, I'm looking at a simple substitution cipher where every single one of these letters represents a different letter. And if I'm writing, you guys, I'm writing in pen, even though I actually did this in pencil the first time. A substitution cipher is one of the most basic ways of encoding any sort of text. You guys have watched Gentleman Jack. Annie Lister, the woman that it's based on, she wrote her diaries with a substitution cipher. She used algebraic notation instead of letters. In the Sherlock Holmes story Adventure of the Dancing Men, all the little dancing pictograms represent a letter. So you can really use anything. Even semaphore counts as a sort of cipher because each flag can represent a particular, or each combination of flags represents a letter. And so by figuring out what the pattern is, by looking at what you have here, you can sort of brute force your way into figuring out what the rule is. And that will allow you to therefore decode the entirety of the message. So when I start doing something like this, always just write out your alphabet again. Luckily, there's a little bitty song that we all learned as children, which I'm definitely singing out loud right now, or under my breath right now, so that I don't mess this up on film, because I'm a professor, so I'm a doctor. Okay, so you write out your alphabet like this, and so obviously these letters are replacing some other letters because we don't have ZML is obviously not a word. So my first instinct was to try out some classic ones because those are often the easiest ones to do. So one of the classic ones is the I think it's called ROT13, and basically it means it shifts 13 points in one direction. And then it's really easy to write out because what you do is you can write A through M, and then you start over here and you have N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, so every time you see an A, it's actually an N, and every time you see an N, it's actually an A. So this is a special little code that's actually still used in cryptography, although most of these aren't anymore. So what you would then do is you have to test it. So this is a hypothetical version of it, hypothesis. So I'm going to look for Z. So if I have a Z here, it means it's going to be an M. So if I do M here, an M here is a Z, and then an L is a Y. Okay, so we're stuck in the same problem because MZY isn't an answer, isn't a word either. So it clearly can't be this particular version. Fair enough, it was just our first shot at it. We'll just cancel that one off and move on. So another classic one that you guys that I tried is the reversal one. I don't know if it has the actual special name, but this is how I just think about it. U T S R Q P. I messed up. I'm out of line here. O N M L K J I H G F E D C B A. Okay, so A is Z, B is Y, X is C, so on. So again, we just test it, and we're always testing with the short words because they're quicker, and there's only so many of them in the alphabet to begin, or in the English language to begin with. So Z becomes A. That's much more promising. M becomes N. Okay, that's actually pretty good. L becomes P. That's good. So Obviously, A and P, not a word either. So scratch that one. And then I thought maybe we're doing a keyword cipher, where you write out your keyword to start off with, and then you go on from there. So I chose NAVSA just as a guess. NAVSA has two A's in it. It makes it a really bad keyword, so because you can't use all of them, but you go NAVS, you skip the second A, you write B, C, D, E, F, G, H, I, J, K, L, M, you skip N, O, P, Q, R, skip S, T, U, skip V, W, X, Y, Z. Problem with this one, as you see, Z is still Z, Y is still Y, and it doesn't actually shift very much. Obviously, Z becoming Z, and then M being Q, it looks like, and then L being H, ZQH, also not a real word. And then I tried Victorian, I tried another couple of keywords. The problem with the keyword version of it is it's not very powerful, and also you run out of keywords pretty quickly. And I'm not a computer, so I gave up pretty much. Those are the classic ones. Those are the ones that I first thought of that tried to just brute force it. There's a bunch of other ones that you could also try. But then I assumed, or moved on to frequency analysis. I have to always look them up, but everyone knows that E is the most common, followed by, I think, T, and then R, S, N. These are common ones. The ones that you get for free on Wheel of Fortune are the ones that I remember all the time. And so what you can do with those is you can say, let's find the most common letter in or symbol in our cipher and see if it's an E and give it a shot. So looking through, I see two L's, I see two B's, I see two W's. All right, well, let's say we know that E happens, comes up as a double letter a lot, so let's just try that. So let's just say all the W's are E's, okay? So if W is E, let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 positions away from W, so that means 8 positions away from B, if we're following the same pattern, should give us a letter that's going to be useful. So 1, 2, 3, 4, 5, 6, 7, 8. So B's are J's. I'm not enjoying this. 1, 2, 3, 4, 5, 6, 7, 8. So that's obviously not right. Okay? But then what we can do pretty easily is you run through and try this as with each of these combinations as you want. So you try E with B's next, and then you try E with L's next. And when you come up to that point, you're like, okay, maybe Lorenzo's too smart to include a bunch of E's in here, so maybe I have to try the next one. So what I then did was I did T, and I did T is B, okay? T is in B, so B, to get to T from B is minus 1, 2, 3, 4, 5, 6, 7, 8. So minus 8. And then so W minus 8 is 1, 2, 3, 4, 5, 6, 7, 8. And then P is 1, 2, 3, 4, 5, 6, 7, 8. All right, so tooth, that is an actual word, so we're getting somewhere. Next thing you start with is L, because I'm just going to move on to the next, because you have to then check all the other words to make sure that they're working. 1, 2, 3, 4, 5, 6, 7, 8. That's a D. And V is 1, 2, 3, 4, 5, 6, 7, 8 is an N. And I is 1, 2, 3, 4, 5, 6, 7, 8. And, all right, so there we are. So the fact that we have two words that match up means that this is probably the one that we go with. And if you go through the whole thing, you get up red in tooth and claw, which, you know, satisfies everything. It's Victorian. It's something that we would have widely known. And then when he brought up a more complicated cipher, he added some extra stuff that I did not work out. But the I just used the things that I knew already. So I knew what these parts are. I knew what this was, so then I could translate and figured out Y over here is an H and so on. So frequency analysis is really helpful if you know what you're doing. I'm not actually that great at it, but once you worked out one of the words and figured out what the pattern is, then you can follow the cipher, break the rest of the code. One of the other ways that you might think about doing it is finding all the three-letter words and trying each one individually and seeing if the pattern holds. So if I tried an and of and or and yo and all of the other ones and seeing if the pattern holds across the thing, I actually ended up looking for uh, five-letter words with double letters in it because thank God for Wordle we have those sorts of technology now. But and that got me to weeks and all kinds of other words that sort of fit this pattern until we got to tooth, and then I could work it out from there. All right, so that was just what I did. Okay, guys, so that was just a really simplified version of what I did. It actually took me about 2 hours of trying different things and lots of different permutations of the particular thing, and I was really lucky because I guessed that it was going to be a Caesar or a shift cipher because those are pretty simple to do. Like I didn't think that Lorenzo was going to force us to do actual high quality math. I hope you enjoyed watching me work it out. Please make sure that if you got invited to NAVSA that you're registering now so that we can get an accurate head count, and you can also take advantage of the early bird special. I hope to see all of you guys in Pennsylvania in the fall.